Hello everyone, thank you for joining for another What's New SOLIDWORKS 2011 webcast. My name's Cody Armstrong, and today we're going over mold design, sheet metal, and weldments. So the first bit I'm going to go over is mold design, and really the only big change in mold design is we created a new option for parting surfaces called manual mode. And what manual mode allows me to do is really tweak those parting surfaces to create something that the default parting surface wouldn't have allowed. Okay, so older versions I really wasn't allowed to change or modify the surface much. With this new manual mode, it allows me to really grab and pull on it and make something that is truly custom. Okay, so let's go ahead and get into it. I'm going to call up a part here. And I have a parting line already established, just unsuppress it. I'm going to go ahead and call up the parting surfaces command. Now in the past, with manual mode off, what you would see in a part like this is a really odd surface in a few particular cases. Okay, and you'll see right here where the surface is almost folding over on itself because of the geometry in here. And unfortunately, in older versions, this is what I was stuck with. This is what I had to use. In other words, I had to have to go in and really do some real surfacing techniques to kind of clean this up. And so there was really nothing I could do inside the parting surface command. With 2011, they've created this new option here at the bottom left in the feature manager. It says manual mode. I check the manual mode, and you'll see what happens is it pops up with a bounding box around the model and a bunch of little pink dots, and these pink dots represent vertices along the split line. Okay, they line up with vertices along the split line, and all I have to do to change the model is grab these pink dots and drag them to the alignment position that I prefer. So let's say I don't want it vertical, I want it horizontal. I can drag it, and you'll see it kind of snaps to the horizontal orientation, and that reorients the surface. Okay, do the same thing over here. You'll see it snaps into place right at that horizontal position. Okay, but again, it allows me just a little more control over the surface that I couldn't have done in previous versions. Okay, you'll see that takes that twist out of the surface. The other thing to note is we've created a new command for fill surface regions. So in a situation like this where I have this half arc, for instance, and I want to, instead of having the half arc like that open, I want to continue a surface from here to here. All I'd have to do is start and end a fill surface region. To do that, you'll notice these little black dots all along the parting line. Those are all locations where I can start or end a fill surface region. So what I'm going to do is come over here, right click on this dot, and this is where I want it to start. So I right click the dot, and you'll see a button here that says Start Fill Surface Region. So I select Start Fill Surface Region. I go to the place where I want it to end, which is this right here. Right click it and say End Fill Surface Region. And that'll create a continuous surface from this dot to this dot. Okay. So again, a little more control inside the parting surface command, which was previously unattainable. Okay. So that's pretty much it for mold design. Let's go ahead and get into sheet metal. A couple of minor changes, but they aren't really minor when you consider the workflow and the day-to-day use of SOLIDWORKS. They are pretty major. And a big one is the ability to mirror and pattern. In the past, we could not mirror, pattern, edge, or minor flanges, and that's no longer the case. The issues always stemmed from how did the model handle the bend information for the mirrored instances. So that's taken care of for 2011. It's no longer a limitation. They've also introduced this concept of a bounding box, which I'm going to describe here in just a couple of minutes. They've made some enhancements to convert to sheet metal, make it a little more uniform among all the sheet metal tools. And then lastly, there's been some updates to the flat pattern command. And I don't have a lot of details on it, but I'll explain some of them when we get to that point. So let's go ahead and get into it. I'm going to go ahead and call up a part. And the first thing I want to start off by doing is just showing that we can now do a pattern of edge flanges. Now, not only edge flanges, but custom edge flanges. You'll see here this is a custom edge flange that's been sketched. It's not anything I just grabbed and pulled on. It's been sketched out and laid out very specifically. And in the past, the limitation is we could not do a pattern of these. And that's no longer the case. I call it the same linear pattern, use the same techniques I'd use for any normal feature, so there's nothing specific sheet metal about it. And then I just select the two features I want, in this case the edge flange and the hole going through it. I set that, I set my space, and I just hit OK. So the workflow really isn't any different than a normal pattern. You'll notice that the bend information is held as a child feature to the pattern. And that's one important thing to note. That's where the bend information is going to be held for those patterned instances. Okay. Same thing goes for mirror. When I go to the mirror command, and I'll mirror about the right plane, just select one of the pattern instances. Notice that it picks up not only the pattern instances, but the seed as well. So I hit the OK, and it mirrors as well. Also, bend information held underneath the mirror command. You see that. Child features of the mirror command. Okay, so both pattern and mirror supported for edge flanges and so on. Okay, and obviously the important bit when it comes to working with sheet metal is the flat pattern and the ability to work with this flat pattern. What they've introduced with SOLIDWORKS 2011 is a bounding box. And this bounding box, you'll notice, is just a construction line rectangle that surrounds the SOLIDWORKS model. And it's the smallest possible rectangle that will fit around the model. That's by design. And what's nice is, I'll show you in just a bit, we can also export this. So this could be used in a lot of different situations. I think of the most common would be, in a manufacturing environment where I nest models. I need to know the stock size that I'm starting with, and that's an example of where I'd use this. But there are a lot, and I'll show you later on how we can export this out when you're exporting your DXF and DWG files. But there are a couple things I want to point out about how SOLIDWORKS handles bend information. The first thing I want to note is just the length of this overall model. Now if I click on the bounding box edge here, it gives me an overall length for the flat pattern, which is 190.74. By default, the bend information is stored as a K factor. Okay, bend allowance information is stored as a K factor. And in the past, with difficult parts, when you have difficult parts like this, where the K factor may vary because of the bend angle, maybe the bend angle isn't exactly 90 degrees, and the K factor information, the bend allowance information, needs to change. And so, in the past, the only workaround really to doing this, to using a K factor, is going into bend allowance or bend deductions. And the problem with those is they can be kind of tedious to set up. They've created a quicker alternative, and it's called the bend calculation. And what it is it maps to an Excel spreadsheet an equation that allows it to vary the bend allowance based on the actual angle of the bend. Okay, so what I'm going to do is I'm going to go back into the flat pattern. I want to point this out one more time just to show how this handles it. With a default K factor of 0.5, this is the overall length. See, 190.74. Now I'm going to change that K factor or bend allowance data to be mapped to my custom Excel file equation. So I'm going to set it to bend calculation. I have the bend calculation already set. So you'll see here. Now really all it is, I'm going to go ahead and call it up, is an Excel file. Okay. And what I've done here is I set the equation, angular range, between 0 and 90 degree bend. This is the equation you call. Between 90 and 165 degrees, this is the equation you call. 165 and 180, there's the equation. Okay, it's very simple. You could even make it more complex than this, but this is an easy way of doing it for the more simple bends. Okay, so I'm going to go ahead and close this out, and I'm going to map this bend calculation Excel file to my part, changing the calculation based on the bend angle. So I'm going to go ahead and hit OK, it rebuilds the data, and you'll see it pops up similar to a design table. And now the bend information, the bend allowance information, is tied to that Excel file as opposed to just a default K factor. And the difference really comes in when I show the overall length of the flat pattern. So when I click on this edge here, you'll see it says 189.64. That was before 190.7 something. So it's 1 full millimeter, or about 40 thousandths of an inch difference in just the bend allowance information. Now that may not be a big deal, but in certain cases it could. It could be the thing that causes it to have a failed model, failed bend. So there are a lot of different situations for different K factors and even differences in machinery. So there are a lot of things to consider. But what's nice about that bend calculation is it allows me a really customizable setup where bend allowance and deductions were always, kind of a tedious manual process. So the next thing I'd like to go over, as I mentioned earlier, they've changed the way they handle flat patterns, and I want to show an example of how I can update my old models to reflect this new flat pattern update. So what I've done is I created a real basic model in SOLIDWORKS 2010, and I'm importing it for the first time into SOLIDWORKS 2011. And like I mentioned, they've made some changes to how they calculate flat patterns, and these changes support a lot more complex rip scenarios and a lot more complex lofted bends. And so it allows me to do something I couldn't previously do in 2010, which is flatten some of these more complex rip and lofted bend sections. So what I want to show is how do I update my model to reflect these new changes. All I have to do is right click Edit Feature to the flat pattern, and if the model hasn't been saved yet in the newest version, you'll see this option that says Recreate Flat Pattern, and it recreates the flat pattern to be updated to this new version. And so what I have to tell people is open up your model in the 2011 version, recreate the flat pattern, and then try creating that feature that was difficult or impossible to do in 2010 and see if you still have an issue flattening it. Okay? So that's the recreate flat pattern option. Again, this is only for files that haven't been opened and viewed yet in 2011. You'll see this. If you created it new in 2011, this option won't be here. Okay, there's one last thing I want to point out, and I can just create a part for this, and that's new functionality to the convert to sheet metal command. Just going to create a real basic block, and the limitations were in the convert to sheet metal command is that you had to specify a thickness. You could not specify using a gauge table. Okay, you had to punch in a thickness, which was kind of different because almost every sheet metal command I can punch in a gauge as opposed to a manual thickness. So now it's a little more uniform. The convert to sheet metal now supports gauge tables, same gauge table set that I use for a base flange, for instance, and it works in the same way. Okay, so some changes to the convert to sheet metal command. Okay, so that about does it for the sheet metal. The big change for 2011 in Weldments is the addition of the Weld Bead command. And the Weld Bead command is definitely much more powerful than its predecessor, the fillet bead. The fillet bead is still there. You can still create fillet beads, but I think once you've seen what the Weld Bead command can do, you probably won't be using it. The other additions to the Weldment support are in drawings. The big changes in drawings, we've created a new table called the Weld table, which I'll show you in just a second. And also, Weldment cut list support and things like that have been updated and modified, so we'll get into those as well. Cut lists, some minor changes to cut lists as well, which I'll get into. So let's go ahead and call up a Weldment. And the first thing I want to note is this is a part, but we're going to get into an assembly as well, an assembly Weldment as well. But I want to show this new Weld Bead command. Notice it even takes the place of the fillet bead on the Weldment toolbar. And it's not that your old fillet beads will be supported. They'll still be there. You can still create fillet beads if you choose to. But this command is much more robust and how it works. So I just want to show some cases where old fillet beads wouldn't have worked. So in 2010, if I wanted to weld this piece of square tubing to this at this angle like this, I couldn't have done it. The limitations were because it met at this weird angle, I couldn't create a fillet bead here. That's no longer the case with a weld bead. I just select the edge I want to weld, say all around for the weld type, and you'll see the pink preview is my weld, and I just said OK. There's my weld bead. Okay. Again, a limitation in 2010, no longer a limitation in 2011. Here's another one. Because of the radius here in the tubing, the weld wouldn't know how to handle the difference between this and the radius, and that was always a limitation with the fillet bead command, no longer with weld bead. In this case, I could just select two opposing faces. Now I could choose, in this case, and it may make sense, is both sides. Say, okay, both sides of the tubing need to be welded, but not all the way around. But what's nice about the all-around is it'll actually compensate. You'll notice if I zoom in at the right angle here, notice how it actually ramps the weld up to accommodate for that radius. Okay, so definitely new functionality there. Okay, so a couple others. If you actually did weld prep, and this always stumped me, if you actually went through the effort of adding the weld prep, the chamfers on the end of the tubing, you couldn't actually add the weld, and that was again a limitation of the fillet bead command. No longer the case for the weld bead. I select the two opposing faces of the weld groove and just say all around. Okay. Lastly, and one of my biggest nitpicks was gaps. They introduced the ability to add gaps either last year or the year before, but you couldn't actually weld the gaps shut. Okay, so now, again, no longer a limitation. Select the two opposing faces, say all around. One thing I want to note about this is it creates a virtual intersection between the two. Notice that the pink preview is not actually touching either face. So it creates an intersection between the two, and that's where it creates the weld, which is, I think, a lot of the limitation of the previous fillet bead command. So I have that, I hit OK, and there's my welds. They've also introduced some new functionality, and I want to go over that as well. So in this case, I want to weld this gusset to the tubing. So I just select the two faces, and you'll see my pink preview show up. And I want to go over the option for an intermittent weld. You'll see it here at the bottom. And if I check this, it allows me to create intermittent welds as opposed to one solid bead. So I'm going to set this to pitch and weld length. I'm going to set my weld length to 20 and my pitch to 30. And you'll see it creates an intermittent weld. Now I also want to duplicate this to the other side, so I'm going to check both sides. You'll see that puts it on the other side of the gusset as well. And lastly, I want to stagger it on either side of the gusset. So I'm going to check the staggered option here, and you'll see it staggers it on either side of the gusset. Okay, so that's an intermittent weld. Next one I want to go over is this from to length option. In the past, I was always forced to, weld basically the length of the edge or the face that I defined by. And in this case, you'll see the preview. Basically, the weld length is the length of the model. Now I can actually customize the length of the weld relative to its edge by clicking this from to length option. And what happens when I click that option, you'll see arrows pop up on either end of the weld. And all I have to do is grab those arrows and drag to manually change the start and overall length of the weld. One thing to note about the way this is defined is you're not defining the start and end length, you're defining the start and overall length. And that's why when I grab on this now, I'm not changing the start and end length, I'm just changing the start and overall length of the weld. And so if I wanted to make the overall weld shorter, I'd have to grab this arrow and drag it. Okay. Just one of the things about the way it works. I'm also going to check both sides here because I do want it to weld on the other side of the gusset. And I can just hit OK. Okay, so that's intermittent welds, from to welds, two new options in the new weld bead command. Okay. So I want to take the opportunity to show some of the enhancements to assembly welding as well. I'm going to go ahead and open up an assembly. Here we go. And the limitations in the past were I could not do the weld prep or the welds right here in the assembly level, and it really kept people from working in weldments and assembly levels. You really did all the weldment work at the part level. That's no longer the case with 2011. I have two new options to assembly features, and those are chamfer and weld bead. What's nice about that is I can do my weld prep and my weld bead right from the assembly level, and there's some quick automation tools that make doing a lot of them in bulk very quick. So let's go ahead and call up the assembly level chamfer command, the assembly feature chamfer. I'm going to set it at 3mm chamfer, and again, what's nice about this is I can just select faces, and it will chamfer the ends of the tubing. Okay, so a very quick way of selecting multiple faces at once. So then once I have that, I just hit OK. You'll see it adds the assembly level feature here, chamfer 1. And now I can go to the weld bead command. If I zoom in here, you'll see the weld prep there. Now what's nice about the weld bead command, and we didn't go over this in the part level, is, for instance, I can select these two faces, say, okay, I want the all-around weld. We did that before. There's also this tool for selecting multiple welds at once. Now the limitation would be, okay, do I have to come in here and select this face and do that again, and then this one again as a separate command? It gets kind of tedious, especially when you could have potentially 50, 100 of these to do. So the Smart Weld Selection tool makes it quick, because all I essentially do is drag this pencil over the joint that I want to bring together. Now it is kind of finicky in how it works. You want to be very careful about the faces that you highlight when you're sketching with this pencil. But if you get it right, it's a very quick way of defining multiple faces to weld at once. You see, defining all these faces at once. It doesn't necessarily have to be the faces I defined with weld prep. I can just define two edges here, maybe over there. Okay, so it's a very quick way of selecting a lot of different weld locations at once. Again, the key to it all, though, is be very careful and very deliberate about which faces you highlight with this tool. Okay, so once I have all my faces highlighted, just hit OK, and there are all my welds. Okay, so that's some of the additions to weldments and working with weldments in assemblies. The next bit I want to get into is some of the enhancements to drawings. The first thing I want to go over when it comes to drawings is with regards to cut lists. And the limitations in cut lists in 2010 and earlier versions is they didn't behave like a true bill of materials. And what I mean by that is you couldn't reorder them. Like, so say for instance I didn't want the end cap as number 13, but I'd rather have it as the bottom of my list. All I'd have to do is grab and drag in a bill of materials, and the limitation was you couldn't do this with older versions of SolidWorks. In a cut list, you got what you got, and you couldn't drag and reorder things. Okay, that's no longer the case with 2011. It behaves just like a bill of materials now. So if I can capture, I'm not sure if I'll be able to get both of these, but it also reorders the balloons. So this gusset here, that's number 15. You'll see if I drag it down to the bottom, it reorders it to number 18. Okay, I don't know if it captured that with the resolution, but it also reorders the balloons. Behaves just essentially the same way that a bill of materials would. Okay, maybe what I'm shooting for is putting all these structural members together in a nice clean order. Okay, so again, I can now reorder the weldment cut list just like a bill of materials. The other thing I want to point out is a new table. SolidWorks created a new table to handle all this new weld information we're putting in. And really it's just a summary of all my weld information. And it's under the usual tables menu. So either insert tables or just right click in the view and go to tables. And you'll see it's called the weld table. So I select weld table. I'm just going to use the default template. And we'll put it up here in the corner. And I just want to point out some of the things it highlights. Weld size, overall weld length, the symbol attached to it. If I established a material, it would pop up here as well. This is part of the default template. And then also the number of times that weld occurs. Okay, so really just a general breakdown of all the weld information that I've added at the part level. Okay, just a couple last things I want to point out with Weldments and the Weld Bead command. Really, the first thing to note is these also add the annotations. I just had them turned off. So if you're used to seeing annotations at the part level, the Weld Bead command also adds them. It's just I had them shut off. So just keep that in mind. The annotations are there at the part level as well. The last thing I want to note is cutlass. The cutlass icons and the behavior has changed a bit. The first thing you'll notice, the icons have changed. The icons now map more closely what bodies they actually are. In the past, these were all the same. Now you'll see structural member icons and regular body icons and even sheet metal specific icons. So the icons in the cut list have changed. You can also drag and reorder. Okay. So that's the changes to cut list, and really the changes to weldments in general. The last thing I want to point out is at the drawing level, inserting these same weld symbols is supported. So I can get all my weld symbols here as well. So the weld bead command obviously creates them at the part level, but also creates weld symbols for the drawing as well that I can insert. So really, that was the same behavior that I get with the fillet bead command. So I just want to point that out that they are compatible in that way. Okay, so let's move on. Some of the different import and export changes for SOLIDWORKS 2011. They've really added some different export options when it comes to DXFs and DWGs. I showed you that bounding box. I kind of got a screenshot of one in there now. You can now export that bounding box along with your DXF and DWG file. And what's nice, like I said, about that is if I take that and put it into a nesting program, it knows the stock size. It's a nice feature. One of the other features is the ability to map all this information to specific layers, which I'm going to go over. So the bin line direction, I can map the bin line direction to a specific layer of the DXF while I'm exporting out of SOLIDWORKS. So that's one of the new bits of functionality. Also, they made some changes to the DXF DWG import wizard. They made some modifications making it easier to bring your DXFs into a 3D model. And then lastly, we've added export compatibility with IFC. And I'm not an IFC expert, but from what I understand, it's mostly for buildings and construction information. But for that industry, it's fairly common. So we've added the capability of exporting as an IFC 2x3 file. And I'll show you that export option, although I'm relatively naive when it comes to that industry. So let's go ahead and get into some of these DXF options. I'm going to go ahead and open up that sheet metal part. I was working on a second ago. And of course we introduced the ability to export a DXF. I can just right click a part, export DXF. I think this was either last year or the year before. So I right click, export to DXF. Save the file. I'll just save this to the desktop. And the export options are here. So I can choose what kind of information I want to export under sheet metal. And of course we have bin lines. But what's new is we have the bounding box information. That bounding box I showed you when we went into the flat pattern, I can also export it as well with the DXF. So if I check bounding box, I hit OK. This is really where the new functionality comes in. SOLIDWORKS to DXF DWG mapping, and allows me to map specific SOLIDWORKS entities to specific layers of the DXF or DWG. So for instance, let's say I have layer 0 here with this line style, and I want to set that to the geometry. Then I go layer 1, that line style, and I want to set this to bin lines up. Okay, we'll go layer 2, and I want to set this to bin lines down, and lastly layer 3. Again, I'm not really original on names, but you kind of get the point. I'm going to set that to bounding box. It allows me to specify specific SOLIDWORKS entities that are going to be mapped to specific layers. And the limitation in the past was, okay, I export as a DXF and I show these bin lines, but how do I know whether they're up or down? And this kind of solves that because it allows me to specify, all the up lines on one layer, all the down lines on one layer. Okay, and it makes it really easy to differentiate between them. So that's some of the new SOLIDWORKS to DXF and DWG mapping options. It allows me to export the bounding box, bin lines, all on separate layers of a DXF DWG file. Okay. The next thing I want to point out is some import options. So I'm going to go into open up a DWG file. I'm going to hit open, and of course if you do a lot of importing of DXF or DWGs, you've seen this dialog before. It's the import wizard. The enhancements have been made when it comes to importing into a new model. So I'm going to import this DXF into a 2D sketch. I'm going to choose specific layers. I don't want all of them. In fact, all I want is a 0 layer. This really hasn't changed much. This is about the same as it was in the past. The changes really come here when I come into my options for importing. Okay, there's some options here. You'll see merge overlapping entities. What that does is essentially takes any overlapping lines that may be in the DXF DWG file and merges them to create one line. And the problems were always in the past when I imported DXF is I could have 2 or 3 lines on top of each other, and when I go to extrude a shape, it says that I have overlapping contours, when in reality I just have overlapping lines, which essentially the same thing, but the software doesn't know the difference. And so what's nice about this is it sees that, merges them to create one solid line, so I don't have to go in and delete line on top of line on top of line to get to the actual one I'm looking for. So that's a nice command to have on. I say merge overlapping entities, takes care of any overlapping lines. The next one, run repair sketch, really doesn't have anything to do with DXF or DWG importing at all. It's just a nice command when working in sketches. But what's nice about it is it detects small gaps in geometry, small instances of really anything. And so it points out where I could have problems in my geometry or small dangling pieces of lines or things like that that could cause problems. So I always say run repair sketch option is a good option to have on when you're running, when you're opening and importing DXFs into a 2D model or 2D sketch. The last thing I want to point out is this define sketch origin option. Some of the limitations were in the past when I import the DXF, it is where it is, and I had to do a lot of manual work to move the entire sketch closer to the origin if it was away from it. And so the problems were, you go to rotate and it rotates out of zoom, things like that, because the origin and the sketch, the origin and the sketch true origin are different, and they're far away from each other. So what it allows me to do is define this origin before it imports it into the model. So all I have to do is click define sketch origin, and I just click where I want to actually locate the origin. So right there. Okay, I hit apply and I just hit finish. No, I don't want to explode blocks. And you'll see it immediately pops up with repair sketch, and that's what that run repair sketch option does. And what's nice about that is it automatically runs, it automatically detects what issues I may have, and it points them out. So I have 12 issues. Just going through them here and kind of clean some of these things up. And very quickly I can go from 12 problems to 0. Okay. Maybe I want to extrude with this, maybe I got to add some extra geometry, who knows, but it's as far as importing process and working with it and creating 3D models from your 2D data, this is the workflow is definitely definitely improved with those new options. So that's working with the new DXF DWG import wizard. The last thing I want to bring up when it comes to importing and exporting, get out of it, is this IFC compatibility. I'm just going to create a real basic model, and you have to forgive my ignorance on IFC. From what I understand, it's just a construction and building information file type, but for those industries, I guess it's fairly common. So I just want to show the option. I'm just going to create a real basic block. File, save as, set my save as type. You'll see right here, IFC 2x3. Okay, I assume if you're in those industries, you'll know exactly what that's for, and now we have export capability for it. Okay, so that is the new IFC compatibility. Okay, so we have a little extra time. So what I'd like to get into are some of the other little tools that a lot of the other guys aren't going to have a lot of time to get into. And in particular, DFM Express and FeatureWorks. And the big change to DFM Express is its support for injection molding. In the past, the Express tool, if you don't use it, it's a free tool that comes with every version of SOLIDWORKS. I'll show you it in a second. It did not support injection molding. You had to get the Pro package to do that. With Express now, you have the support for injection molding. We can map to that one rule that's there. So it's definitely new functionality for 2011. FeatureWorks has also been updated. There's been a lot of modifications to FeatureWorks when it comes to support for cut sweeps, support for drafts, really support for a lot more features in general. And in the past, the FeatureWorks models we got were just a lot of bosses and cuts because it couldn't create a lot of these more complex features, and that's no longer the case. I can create sweeps, I can create drafts, I can create all the complex stuff that I couldn't do in previous versions. So let me show you a couple examples of these. I'm going to start off with DFM Express. I'm just going to open up a real basic injection part. Nope, I'm not going to run it for this one. Now, if you haven't used DFM Express, it stands for Design for Manufacturability. It's here in the Tools menu. It's a very simple tool to use. It basically tests your model against a set of rules. And in the past, the limitations were that in 2010 and earlier, you didn't have this injection molding option. Okay, I had mill drill only, turn with mill drill, and sheet metal, but I did not have injection molding. Okay, so that's new for 2011. I'm going to check injection molding, and you'll see the rule that pops up. There's two rules, minimum and maximum wall thickness. And really what I'm specifying is between this and this value is an acceptable wall thickness. Anything outside of those, it is a broken rule, and I want to see it. Okay, so I know that the model intentionally designed for up to a 6mm wall thickness, so I'm going to go ahead and set that to 6 and hit run. And really that's all you have to do. Set your rules, you hit run, the software analyzes the model, and then tells you anywhere where those rules were broken. And if you haven't used this, there's a lot of different manufacturing scenarios where you could use it. But you'll see there, as soon as it's done analyzing the model, it pops up with all the rules failed and the rules passed. And if I go into specifics, you'll see there are a couple instances where the wall thickness, see here, maximum wall thickness is 7, whereas it's recommended to be less than 6. So it's showing me every instance where the wall thickness is more than 6, and there are a few. Okay, so it's a nice tool for those working in the injection molding area where they're creating their plastic parts and they need to be really concerned with constant, continuous, wall thickness. Okay, so that's some of the improvements to DFM Express. The last thing I want to bring up is FeatureWorks, and I'm going to import a couple of Parasolid models. Let's start with the boss sweep and show some of this new capability for FeatureWorks. So yeah, I'll run import diagnostics. Do you want to proceed with feature recognition? Yes. let it call up FeatureWorks. And the thing I want to point out is in the past, when I did an interactive feature recognition, it did not have options for cut sweep, boss sweep, a lot of these more complex features. Okay, with 2011 I can now support things like boss sweeps, cut sweeps, draft features. So I'm going to go ahead and define a boss sweep, and I just select the two faces that represent the sweep, both top and bottom, and then I just hit OK. And you'll see what it creates is a feature complete with sketches that I can edit. Okay, and that's really the key to all this, is I want to create something I can edit. Okay, so this is working again with imported geometry, creating features out of it so that I can manually edit, make some design changes. Okay, so that's creating boss sweep. Same thing with a cut sweep. So I'm going to go ahead and open up a model and show you an example of the cut sweep. Really, the steps are the same. For inserting a boss sweep and a cut sweep, I have to define the feature type first. So I define a cut sweep. Then I define the two face sets, so the top face and the bottom face of the sweep. And I just hit OK. And it creates a cut sweep again with two sketches. Sketch 1 and sketch 2. Okay, so again, that's creating cut sweeps with imported models using FeatureWorks. The last one I want to point out with FeatureWorks is draft. That's always been a limitation with FeatureWorks in the past, is it would not pick up any draft. So I'm going to go ahead and call up an example. Now with draft, what's nice is I don't have to run it in interactive mode. It will automatically pick it up. As long as I shut off some of these other features, I only want to pick up draft and fillets and chamfers. You'll see it's got a couple of fillets here as well. I wanted to detect those as well. So I'm going to go ahead and set it just to drafts and fillets and chamfers, and go ahead and hit next. You'll see it runs through the recognition, and then what it's going to do is give me a list of features that it recognizes. Okay, I go ahead and hit OK, and it adds those features to my model. Okay, so you'll notice draft 1, draft 2, fillet 1, fillet 2, all features I can edit and change now. Okay, so now working with draft and FeatureWorks is definitely a reality. So that is pretty much it for what I have for this webcast. If you have any questions, don't hesitate to send an email to support@ddicad.com. Thank you for joining.